Hello everyone. In this video, I will be presenting my assignment 3, which consists of two parts. Part A, which focuses on image convolution, and Part B, which is about building and training a neural network. I will explain each part briefly, show you the code, and display the results. Let's start with image convolution. Part A for the assignment is about understanding how convolution works on images. Convolution is a mathematical operation used to detect features in images such as edge or lines. I use different convolution kernels to highlight horizontal, diagonal, and edge features in an images. Okay, here you can see the code detecting horizontal lines. I use a kernel that emphasizes horizontal chains. The kernel used here is as follows. Here is it. This code detects horizontal lines by emphasizing row of pixels that change significantly. After applying this kernel, the output clearly shows the horizontal edge. Okay, now go to diagonal line detection. Here is it. And I also created a kernel detect diagonal lines at 45-degree angle. The kernel used here is that one. This kernel highlights diagonal patterns, particularly at 45-degree angle. You can see diagonal lines more clearly in the output image. Okay, edge kernel, edge detection, here is it. Finally, I wanted to speak a little bit about edge detection. I applied kernel to detect edge. The kernel used here is the kernel helps detect edge by emphasizing the change in pixel value. You can see that edge of objects are much more distinct in the output. Okay, now we are going part B. Part B mainly about neural network and training of the neural network. In part B, I built neural network with keras to classify images, and the model consists of convolutional layers for feature extraction, pooling layers to reduce spatial dimensions, and dense layers for classification. Here's a model architecture code. This model has 5 layers, and each layer has a functionality classification, how to extract features, pooling layers reduce spatial size, flatten layers prepares data for dense layers, and dense layers perform classification. Okay, I want to talk about adding dropout. Here is a code how reduce overfitting. I added dropout layer. Here is a code. Dropout randomly drops 30%. narrow steering training, which help model generalize better and prevents overfitting. Accuracy curve here is see. Okay, here's the accuracy curves. You see, here's a comparison of accuracy between the original model and with dropout. As you can see, dropout model has more stable accuracy, is less prone of overfitting. You see. Okay, and in summary, part A demonstrates how convolutional kernels help detect horizontal, diagonal lines, and edge. In part B, I built neural network to classify images and use dropout to reduce overfitting. The model has dropout. Uh, the model, uh, the model with dropout performed better, and it was more generalizable. Thank you for watching my video. I hope you found explanation clear and informative.